Welcome to the video tutorial for Unit 7, Day 2 homework. This is over pages 3 and 4 in our homework packets. Okay, the first thing we need to practice on this is how to enter this number into our calculators. If you were in class and you did that, you know how to enter it, you can fast forward a little bit. But 6.02 times 10 to the 23rd needs to be entered into calculators. Remember, if you have your own calculator, that's fine for homework, but you have to use the class calculators when we take tests, which makes it really important that you know how to enter it in here. And for each calculator, numbers are in a slightly different spot. So 6.02 times 10 to the 23rd power. We're going to do it like this, 6.02, and then you need to find the EE button, which is right there. When you push that, you get a capital E. And capital E means times 10 to the blank power. Okay? So what we just did was put times 10 and the power symbol, 23. Enter. That's it. 6.02 E23. That's how you enter that number. If you try entering it as times 10 to the power, you have to do parentheses, 6.02 times 10. Then you have to hit this Xbox button, so your cursor moves up, 23. Then you have to hit the over button, and then close your parentheses. It's a lot more work, and a lot more likely that you are going to make a calculator error. Okay, so again, how we enter Avogadro's number is 6.02 EE23. So if you want to multiply that by 5, then you just say times 5, and you do not need parentheses. So your final answer, 3.01 E24, is 3.01, but we don't write E on our answers. That means times 10 to the 24, okay, because this is E. All right. So then let's look at some of these problems. We did dimensional analysis with liters and gallons and miles and feet last class, and now we're using that process with more complicated numbers in chemistry. So we still have to box in your given. Okay, that's number and unit, and then circle your unknown. All right. So we're going to take a look at number 3 together. It says, what is the mass of 3.62 moles of water? So my given is 3.62 moles. Not just 3.62, but 3.62 moles. Remember, for dimensional analysis, the units are our best friends. And what are they asking me? Mass. So now I've taken out all the distractions, and I know the only things I need. So I draw my T-chart, and I'm going to start with one step, so one vertical line, and I put my given always in the top left-hand corner. So my given was 3.62 mole. You have to include the unit, because what we do next is disco down moles. So we disco our unit, so top up here comes down there, so we're going to put mole. Okay. Now whatever I put on top has to be equal to mole. So ideally I want to put mass here. So let's see if we know an equality about that, because the top has to equal the bottom. So come up here. A mole equals this many particles, but that's not what we want. We want to go to mass. 1 mole equals the molar mass. Okay? So on top I can say grams per mole. So 1 mole equals the molar mass of water, which is fine, but now we have to calculate it. So this will get me to my unknown, to what I want to know. So remember water, and I'm going to show some work over here, is H2O. So I'm going to say 2 times hydrogen, which is 1.008. I just got that off of my periodic table. And that should be 2.16, 2.016, excuse me. And then I just have 1 oxygen. So 1 times oxygen equals 15.999. So when I add those two together, I get 18.015. So I can say, this is true, my top equals my bottom. 1 mole of water does weigh 18.015 grams. That's the molar mass, the mass of a mole. Perfect. So then we multiply the top numbers and divide by the bottom. So we're going to say 3.62 times 18.015 divided by 1 doesn't change anything. So my answer, all right, moles is on top and bottom, so it cancels out. So my unit is just grams. So I'm going to say 65.2 grams. Your answer has to have a unit in it. Okay? Great. Look at number 5 then. The first thing we always do, box in our given and circle our unknown. They're asking me how many strontium atoms. Okay? So I start with a simple T-chart, and I put my given in the top left, which is 3.42 mole. So I always know the next thing is just go down my unit. Whatever was up here comes down. Mole. And I'm trying to turn it into atoms now. So I want atoms on top. But I need to know how many atoms equal how many moles, and Mr. Avogadro tells us that. Right? Avocado's number equals guacamole. Ugh. Okay? So 6.02 times 10 to the 23rd. And yes, you do have to write the whole thing out every time. 23rd, incorrect. Now I say atoms. How many moles equals that? Mole does. So my top equals my bottom, and my unknown is in my top right. So I'm done. One step. We love it. 99% of your problems is now going to be entering this in the calculator wrong. So I'm going to multiply by the top and divide by the bottom, which is 1. So really I just need to multiply by the top. So be careful how we do this. 3.42 times 6.02 times 10 to the is the EE button. Because it makes everything easier. Alright. 6.02 times 10 to the 23rd. Okay, then we hit it. Go divided by 1. We hit it. Be careful here. Hidden way at the end of this decimal is E24. So sometimes students will just say the answer is 2.05. It's not. Okay, it's 2.0, and you can put 058 or 2.06. And we'd say times 10 to the 24th. Okay, if you just put 2.06 or E, then E24, then you'd get it wrong. And again, that's not a complete answer. We need units. So we'd say atoms. There we go. So what's nice is because we have these conversion factors, most of these problems are just going to be one step, as opposed to yesterday we were doing 3 steps sometimes. Alright, let's look at page 4. Alright, and we'll start here. Number 9. How many moles are there in 7.50 times 10 to the 23rd formula units of sulfuric acid? Woof. Right. Where's my given? This is my number and my given unit, so I box the whole thing in. And what are they asking me? They're asking me for moles. So I start with my T-chart, and I put my given in my top left, which would be 7.50 times 10 to the 23rd. And you can abbreviate formula units, which, yes, does abbreviate to FU. Ha, 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 ha. Yeah, FU. Okay. And then we know what to do next. We always just go our units down. So we're going to put formula units down here. And formula units sometimes throw students for a loop, because they're like, I don't know formula units. So this is where you have to remember Avogadro's number. 1 mole equals this many basketballs. 1 mole equals this many atoms. 1 mole equals this many formula units and molecules. Okay, so even though it says formula units, it's still this number. So this many, 6.02 times 10 to the 23rd, equals 1 mole. But Mrs. Holm, I thought 1 always had to be on the bottom. No. Formula units is on top here, so it has to go on the bottom there, which puts 1 mole on top, and that's okay. So now I multiply the top, and that's going to keep it the same, and then I divide by the bottom. So be careful, again, how you enter this in your calculator. 7.50 EE times 10 to the 23rd. All right, divided by, because it's on bottom now, we divide by the bottom, 6.02 EE 23. So that would be a total of 1.24. We check, there's no E back there. So 1.25 moles. 1.25 moles. And if you look at it, that kind of makes sense. Right? Formula units cancel out. There's my final answer. This is just slightly bigger than Avogadro's number. So this answer should just be slightly bigger than 1 mole. And what happened to the times 10 to the 23rd? The times 10 to the 23rd was on top and bottom, so it canceled out. Remember, when we multiply and divide by the same thing, it goes away. 10 times 3 divided by 3 is still 10. Alright, let's take a look here now. Our given, 127.0 moles, our unknown mass of NaCl. So they want me to find grams of sodium chloride. So sodium and chlorine, +1, -1, crisscross. The formula for sodium chloride is just NaCl. Alright. My given goes here still. 127.0 mole. Units, units, units. So that I can disco that unit down. Mole. And I'm trying to turn it into mass, which is grams. Okay. So how do I know how many grams are in a mole? I have to find the molar mass of it. 1 mole equals the molar mass. I'm going to say 1 mole equals the molar mass, in this case of NaCl. So I need to take 1, whoops, I'm not on camera, sorry. I need to take 1 Na plus 1 Cl. No rounding, people. Not when we're entering into the calculator. 22.990 for sodium plus 35.453. Oops, I did times for chlorine. Let me fix that. Plus, that's going to give me a good answer. 58.443. That's how much 1 mole weighs. So the mass, 58, what did I say? 58.443. The mass of NaCl is the same as the mole of NaCl. So I multiply the two top numbers, and then I divide by the bottom. So in this case, I do this number, it's already in my calculator, times 127.0, and then divided by 1 doesn't change anything. So I'm going to say 7,422. Alright, students are always asking me about rounding, and the answer is there are very, very specific rules for when to round in chemistry and science. They're called significant figures. We have the rules written here. They're a pain in the darn butt. Okay? So really what you're looking at is however many numbers I kept in my given. 1, 2, 3, 4, that's how many I want in my unknown. If you put 7,422.26, we're going to say that's fine. Okay? We're not going to bust you on that. But we have to have a unit. Moles canceled out, and so my unit that's left over would be grams. Please make sure that you are showing work for these ones as well. Okay. Come in if that wasn't enough help for you. Thanks, guys.